Okay, well, here we are. It's 11:01, so we'll just go ahead and get started. I see people are still joining, but my name is Jim Harris. I'm the Director of Sales for ACTEGA North America. Appreciate everyone taking time out of their busy schedules to attend our webinar on the technical aspects of IML coatings. We have two of our resident experts from Germany joining us to discuss this topic with us today. So the next slide here, sorry. Oh. There we are. Great. We have Frank Campus. Frank is our head of research and development for water-based coatings and adhesives. Frank has extensive experience in developing all types of different chemistries and is one of the main people responsible for our state-of-the-art IML coatings. And we also have Andre Soterio. Andre is the head of sales for our division in ACTEGA Terra in Europe. And Andre comes with a great deal of experience both on the substrate side of the business and obviously here with us at ACTEGA. So without further ado, again, thanks. We have people from all over the globe attending today, and I'm going to hand it over to Andre so he can get the webinar started. Thanks again.
Thank you, Jim. So there are many ways that we can decorate a product. So if we see about some of the main technologies used, we have pressure sensitive labels. It's one of the most used technologies for decorating products. It represents about 40% of the total label market technology globally. We have then glue applied labels. It's can be wet glue labels or wraparound labels. It has a very big market penetration worldwide as well with 35%. We have shrink sleeve, very popular for its 360 degrees decoration. Widely used nowadays for many types of products. And if we see IML, it's really very small niche market. IML represents about 2% of the global label market technology worldwide. Very popular in Europe, especially injection process. In the United States, no, in North America, we are quite famous for blow molding, and injection is growing. But we can see IML worldwide from South America to Australia, New Zealand, Asia, so everywhere we can see products decorated with IML.
Hey, Andre, if I could just interrupt you for 1 minute. I just realized sure. I forgot to mention something. During the presentation, there's a chat pot down in the bottom right corner of the screen. If you have any questions along the way, any of the participants, please feel free to type those into the chat pot. We'll do our best at the end to address those questions. If we don't have time, we'll be sending out those questions with the answers to the attendees as well. So we will have some questions at the end, but if you want to type those in there as we go along, feel free to do so. Sorry, Andre.
Don't worry, no problem. Thank you, Jim. So IML is a quite niche market compared to other label technologies like pressure sensitive or shrink sleeves. It's a very technical, innovative market. Just a few companies have the technical know-how how to produce good quality IML labels, and it's very difficult for new printers to start IML production. And in order to do so, they have to have a lot of knowledge, and one of the main components of this total production is the coatings, and that's why we would like to present today a little bit some of the technical points that you have when you are using IML. So if we think about it, why people use IML, there are many important points on that one. So one of the main uses for IML is the product is decorated in one step. So during the production of the plastic, you are decorating at the same time. So it saves some of the production process. It's a very high value decoration. It's one of the best print quality you can get, with high resolution image, small fonts, very fine and detailed barcodes. You have a no label look, depend on the film used, depend on the design. It's fully integrated into the packaging. The label is fully integrated in the packaging. It's also environmentally friendly. The IML labels can be recycled together with the total packaging. Less plastic is used in the production as well. It's a very high cost efficiency for high quantities. Very easy from switch from one product to the other, just changing the labels during the production. And has a very high resistance against abrasion, chemicals, humidity, heat, or frost. Coming a little bit to the technical part, there are some two main ways to produce IML. One of the very popular method used in North America is the IML blow molding. It's mainly used for plastic bottles, mainly HDPE, high density polyethylene. So here you place two pre-printed die-cutted labels into the mold. These labels will be held by static. That's a very big, by vacuum. That's a very big difference compared to injection that we're going to see later. In the same time, there is a kind of a plastic molten tube, or what we call perisome, coming down on the extruder. This is just like a small tube, and this mold will close, hold the perisome on top and bottom, and the machine will blow hot air into this tube, and the tube will take the form of the mold. As the tube is still hot, it will touch the back side of the label. The label will melt together with the bottle. The mold is cooled down, and we have the fine product. The second method, very, very popular in Europe, it's the IML injection. Here you have also pre-printed labels and die cut. It's put inside in the mold using static. That's really big difference to blow molding. This mold will be closed down. Hot plastic will be injected into these molds at about 240 degrees, which is about 400 degrees Fahrenheit. This plastic will take form of the shape of the mold. It will melt with the plastic, mold will cool down, and you have the final product. Here we have as well one main important point when using IML is, of course, a combination of the film, inks, and coatings for the printer. One of the main important points on that one is, of course, the film usage. So in the injection molding, most films are used are OPPs or CPP films. The main differences between one is the oriented polypropylene, can go from 50 to 90 microns. And on the CPP film, which is a cast polypropylene, it can go from 80 to 100 microns. It's mainly, cast PP is mainly used for large containers like paint buckets. And both of them can be widely printed by offset or flexo, depending on the printing method decided, or even digital. I would like to go now a little bit more on the technical part, especially about coatings. Right now, I'd like to pass the ball to Frank, who has a lot of experience on technical side, and Frank will explain a little bit about the coatings, a quick look behind the scenes. Frank?
Yeah, thank you, Andre, to explain the processing in the beginning. And now we are talking about coatings, and the job of a coating is to secure the print, but for coatings for IML, that's much more we have to be consider. So if you see the whole processing for IML injection, you have 4 topics you have to keep in mind. That is providing the coating or developing the coating, but the production by the printer, then the injector, and in the end to fill the filling processing from the filling goods. And for the IML coatings, there's a lot of properties it's necessary to design in the coating. That means in the beginning, of course, the main topics is to secure a good printing property, fast drying, take care about curling, and most important is heat resistant, and to keep static load, a static charge, and water resistant. And if you go back, if you go further to the production, then you find it again. That means that you need a good printing properties, that the coating provide a good printing properties, a fast drying, be carefully by curling, and by injection you have still the same importance of curling, heat resistant, static load, and by the filling station again kind of water resistant, heat resistant, that you fill in a secure way. And that comes to some basic about the coatings. In principle, there are 2 technology in the market, UV coatings and water-based coatings. And when we're starting with the UV coating, it's based on epoxy acrylates, monomers, contain some photoinitiator and additives. And to dry this UV coating, you need UV light, and then you are doing a chemical reaction. By water-based coating, you have also some polymers based on acrylate, styrene acrylates, some waxes, some silicones and wetting agent. But more important, you have a solvent, and the solvent for a water-based coating is water. And that is very important, that we are not using any other solvents like alcohol or glycol ether. To dry a UV curing, a UV-based coating, it's a curing. That means you have the liquid film, and with UV light, you have a chemical reaction, a polymerization, and then you get the cured film. That means if you apply a 100% liquid film, you get a 100% cured film. If you apply 5 grams per square meter, you get 5 grams per square meter. If you apply a water-based coating, then you have to think that there's a solvent inside, that is the water, and you have to evaporate the water with infrared and hot air, and then this polymers melting to a solid film. So if you apply 4 grams liquid water-based coating, you get 1.5 to 2.0 gram per square meter solid film. Here you see a picture with a microscope about the dried IML coating. This is a water-based coating. So here you have a white about 3 micron. That is a good property of a coating. It's it's the right way, because you have to protect the ink and the film for later mechanical stress and for heat. So for applying of oxidative inks, you need minimum 5 grams per square meter wet of a coating. that's 0.001 lib per square feet. For UV inks and LED inks, you can reduce a little bit. But if the coating amount is too low, you get problems in further processing. Okay, Andre, I went over to you again to compare a little bit the water-based and UV coatings.
Thanks, Frank, for the explanation. As Frank said, there's a very big difference between water-based and UV coatings, and here we'd like to show to you a little bit comparison during the process between UV and water-based. So here in Europe, actually, 90% of the printers are currently using water-based systems. A few of them are using UV, and here we can see why they are using UV, or what are the advantages of UV against water-based. So first of all, in UV coatings, you have a very big advantage, is the high gloss. Very difficult to match the high gloss that you get with UV with a water-based coating. Even if you use high gloss water-based coatings, you get a big difference between on top of the ink and on top of the film itself, no ink underneath. The second main advantage of UV coatings is the rub resistance is far better than water-based coatings. Then we have higher coating thickness, as Frank said, has no evaporation of the water. So what you apply, you can get it. It remains on top of the film. So sometimes you can, depending on the application, depending on the level of resistance you need, you can apply a very high coating thickness. Fourth one is a chemical resistance. UV coatings depend on the kind of product that you are using, like acetone or some very hard chemicals. It will have a better resistance against water-based coatings. And finally, higher mechanical resistance, which will be similar to a rub resistance. But UV has also its disadvantages. Although we think about it, that UV has a very good rub resistance, UV coatings have a very low water resistance. So this is one of the really big disadvantage when using UV coatings. The second one is the higher cost compared to water-based. Third one is adhesion to films, depending on the film treatment, on the application way. It's sometimes you can have some adhesion problems, and you will need to use a primer for improving this adhesion, which means an extra product. This is also one of the defining points, is the static pinning for the injection. So with UV, depending on the way you apply, depending on the usage, you might have some static pinning problems at the injection site. Then we have as well the lamp maintenance. Lamp maintenance is one of the most important things when using UV coatings. You have to change the lamps often, that you have a good curing of the labels of the coating, and consequently good quality labels. Again, curling is a very big issue. Frank explained that one, that during the printing, during the injection, people are really afraid of how it's going to be the curling behavior of the labels. And UV is really an issue on that one. If you cure too much the labels, you might have a completely curled surface of the labels. And another very important one is the food application. A lot of people are afraid if there will be some rest of photoinitiators in the labels, in the coating, that can migrate to the food or to the inside of the packaging. So for that reason, people try to avoid using UV, even if there are nowadays some low migration UV coatings. If we look about on water-based products, we have a lot of advantages. As I said, one of them is direct food contact and indirect food contact. Water-based are much easier to control for that usage. The other one is the water resistance. Although it's, as Frank said, it's diluted in water. As soon as this water is gone and you have a very nice dried polymer film, it has sometimes most of the time an excellent water resistance. It has a better static control during the printing and die cutting, but when you charge that with static, and we're going to see that later, as soon as you charge that with static, the label will stain on the mold. And that's one of the main issues why people use water-based coatings, because it's a very reliable system. This is not really a very popular or very defining property of the coating, but a lot of people sometimes they want to have a very nice overlapping of the label. Like if you think about margarine labels, margarine tubs, it always has some overlapping on the sides, and people want to see a very nice overlapping, and water-based coatings can provide these properties. Flatness of the label, which is you will not have curling. It depends a lot on the product, the coating used, how you print it, and we're going to see later on the technical specifications. Again, a very good separation of the labels. You don't have like a glass effect between the labels, and an economical advantage because water-based coatings normally cost less than UV coatings. But water-based coatings has also some disadvantages. As I said, is the limited mechanical resistance, especially rub resistance, and limited alkali and chemical resistance. I would not enter so much here in details about the products we have, but this is our global portfolio, global IML product portfolio that ACTEGA offers to customers. We have here on the left side, we have the visual appearance, if it will be gloss or matte appearance, and on the axis we have the special characteristics. So one of the main product that we have is the Aquaprint 200. Is our standard product. It's really in the middle. Is one of the biggest. It's a very big circle because it's one of our most bestseller products. It's a semi-matte product, and it's really in the middle. With this coating, you can cover probably 50 to 80% of your needs. We have as well some products with a little bit more resistance, like overlapping and water resistance. That's a product called Aquaprint 115. We have the Aquaprint 202 is for row printing, like UV offset row to row, and then water-based coating at the end. Then some matte products, very good for spot UV printing. So you print a matte coating on the 100%, and then you use it with a UV spot printing to have some matte gloss effect. Then we have the Aquaprint 215. It's a high gloss coating, but as I said, it doesn't reach such high gloss compared to a UV coating. And then very special product is for pasteurization application. It's the Aquaprint 115. After you print that one, it's like a glass. It's really high water resistance and completely close the surface of the film of the label. For some special applications, we have as well a water-based primer, what we call an auxiliary product. The Aquaprint, the G16-140 is a water-based primer. You apply that one before applying with UV flexo inks to have a better adhesion of the UV flexo inks on the films. And last but not least, we have the UV high gloss product. We call it G8389. It's called the food class because it has low migration, low odor, very high gloss, can be used on the top of UV flexo, offsets, and as well on the top of digital like HP Indigo inks. And that said, I'll pass back to you, Frank, where we're going to see the important technical points when using our IML coatings. Frank?
Okay, thank you, Andre, for the overview about the portfolio. Now we would like to get deeper in technical points. That means to apply the water-based IML coating, you have to follow some advice. And if you do it, then you get the label in the right way. At first, the water-based coating, I explained, contains some waxes. These waxes can get some skin on the surface, on the liquid coating. So if you open a drum, maybe you have a semi-solid skin on that. Don't worry about that. That is right. You need it. So for that, we recommend to steer with a mechanical steerer so that you steer it in the right way by electrical or by pressure with air. Please check the viscosity, that you have the right viscosity. Here we have an information for you about the depending on viscosity and temperature. That means if the temperature decrease, viscosity is also increase, and if it get hotter, then the viscosity decrease. Don't worry about that. Measure the viscosity before the production starts, and if viscosity is a little bit too high, you can add water. That's not a problem. And take care about your storage and your goods. So use first in, first out. The coating application is via an Anylox, so that if you use the Dr. Chamber blade and Anylox roller, then you have a homogeneous layer of coating. You can easily change a coating and you can clean it with water. So you have your Anylox roller and apply it to a plate, and then it's applied to your substrates. And in principle, there are two different roller on the market. That is a cell roller, like a hexagonal, or you have this line roller, the tri-helical Anylox roller. For IML, we recommend the hexagonal roller, and if you're using an offset oxidative drying inks, then we recommend 9.7 to 11 BCM to apply the right of the coating. If you are using UV ink or LED ink, you can reduce a little bit the amount of coating, and you can using 7.2 to 8.4 BCM roller. Why we recommend the hexagonal roller? Because by tri-helical, we saw in the practice that you have a higher risk of coating age of when you apply the coating. What about the maintenance of an Anylox roller? That is very important. An IML water-based coating dry much faster compared to standard coatings. And that means if the coating is dried in an Anylox roller, it's difficult to clean. So you have to clean daily the Anylox roller with water or a common cleaner. And 2 times per month, we recommend a refresher, so a deep cleaning of the Anylox roller. And it makes sense and it's very helpful 2 or 3 times per year that you clean your Enilox roller with ultrasonic. And here you see a picture. If this Enilox roller is dirty, dried, coating, then could not apply anymore the amount of coating what is necessary. And after cleaning, you have the cells very nice cleaned, and you can apply the right amount of coating. The same we recommend for the coating unit. So what I explained, the coating dried very fast, and if you have a stop for several minutes or in the end of the job, please at first clean your coating unit, that you avoid here drying of the coating on the roller and on the plate. Check your coating plate, that's really clean enough, and yeah, clean early enough. What about the drying of the coating and offset processing in the coating unit? So that is what I explained. You have to evaporate the water. It has to leave the coating film. And if you have the coating unit in an offset processing, you have IR dryer and hot air. And we recommend don't use the automatic set for IML. It could give you a wrong setting. So it's better to take it manually to see, okay, what you need is the air flow on maximum. That means dry air comes in the system and wet air leaves the system. And the practice show that you have to adjust the hot air between 160 and 180 Fahrenheit, if possible, and you have a cooling air in the end of your station. That is an advantage. Then please check your pile. So pile temperature should not increase over 85 Fahrenheit. So please check it and never use more than 95 Fahrenheit. Yeah, if the sheets are completed, then keep in mind, if you're using oxidative drying inks, this drying inks need the oxidative drying, so it's also a chemical reaction. And for that, the inks dries slower than the coating itself, and that means for further steps you have to wait 48 hours, and it makes sense to air the sheets good enough, control also humidity to avoid curling or problems in static charging before the cutting is done. If you're using UV inks or LED inks, even if the ink is dry immediately, please keep in mind that you can have some humidity inside, and that could also cause some problems. So we recommend to wait 24 hours. If you are working in a flexo processing, you can use both UV coating or water-based coating. So again, recommendation of Enilox roller is roughly 7.2 to 8.4. And it's important that you're adjusting your dryer. That means, for example, for UV processing, the energy of a UV drying lamp is very intensive. So if it's too much, that could be get problems by curling, or if an IR dryer is too high by water-based coating, it could be also some problems. Yeah, in offset printing, the sheet fed, you need some powder. So, and you have to check, is the powder compatible with the water-based coating? So never please never use the mineral powder. Use a starch-based powder. And this powder is avoiding the set-off in the sheets, that you have some airing between. And please use powder, but not too much. So you have to adjust the right quantity. So, and we recommend 20 micron spray powder for the processing for later IML processing. Here you see a picture of building set-off in the mold. That means that it's a white, cloudy substance get out the labels. That is the most complicated issue for IML, because it's not easy to find a curse. And there are some possibilities. Mostly it's too much powder, or the ink is not cured good enough, or you have a lot of humidity inside, maybe higher temperature. In some cases, the coating is overdosed, so that is too much coating on site. And beside to using too much powder, the most mistake is to use a wrong coating. So if you are using a standard coating for IML, even it works in the beginning, that's only a question of time that you get big problems with this technical topics. So if you find some problems in your production, please ask us. We have a solution for this problem. Yes. Then curling. So sorry, here's a mistake. So that's not set off in the molding, it's curling. So
yeah, correct. Curling. Sorry.
So we there's a small mistake in the today from the presentation, but no problem. So yeah, behind the set off in the mold, there's a problem in the curling. Here you see a picture. So if you have curling of the labels, then you can't fill the station in a properly way. And mostly it depending on the label itself. That means you're using films, and in these films there are several layers. Then you add ink and coating on the top, and then you get more layers, and that could be curling by differences in temperature and humidity. And so it's very important that you check your conditions, that you are not too dry in the air, but also not too much humidity in the air. And by the intensive energy you bring on by UV curing, so UV coatings are more sensitive by the curling compared to the water-based coating. And if you have some curling problems, mostly it's depending on film and humidity and conditions, but in some cases we can also help with some different coating recommendations. In that case, please contact us. Then the static charging, I would say that is the most important topic of the label and the coating. So in every case, if you are using the wrong coating, then you are lost, because you can't repair this issue. So the first is that you are really using a right IML coating, because in the quality control that should be checked that the charging is in the right way. So because the IML processing, Andre explained it, we have to the label have to get the right position in the mold, and then you get the liquid plastic. And if the charging is not good enough, then the label do not find the right position, and this is a disaster by injection molding, because then you have to stop production and you can't repair anything. And for that, it's very important also to checking the climate atmosphere. So, for example, if it's too wet, too much humidity in the air, then you will losing also the charging of the label. And it's right what Andre said. For UV coating, it's more difficult to handle this situation.
Correct, Frank. And then we had someone asked here as well about, can you explain the challenge UV has in pinning more detail? So that's the main problem when you have a coating, UV coating, and you want to avoid static during printing and die cutting, and you try to apply the static for putting the mold, the most probably the coating will not have these both sides. That's the main issue with UV coatings. That's really difficult to use. Yeah, that's the point on that one. So there was a question on that one. I just want to take the opportunity to explain. Thank you, Frank.
Yeah, okay. To underline it for all the auditorium, that's really the most important topic. So static charge, and the second I explained now, it's heat resistant. So if you are using the wrong coating, it's not heat resistant enough, then you get big problems, because in the injection processing, even if the mold is cooled, so you have the injection point. Here you see the injection point, and there you have a peak temperature, and that means you get easily over 400 Fahrenheit. And if the coating is not heat resistant, then it's melting in that point and destroyed completely. Here you see it, that is completely destroyed, or here you see that the film will also get melting. And so I strongly recommend to use the heat-resistant coating to avoid burning of the complete labeling. Okay, Andre, what do you think? Did I explain the most important topics for IML coating?
Yeah, Frank, I think it was well explained. I think from all this technical explanation, I think, as you said, there are 3 or 4 main points. Is heat resistance of the coating, the static, the analog selection. This is one of the top ones, and as well the mixing of the coating. If you don't mix well the coating, you will not have a problem. But when you follow up all the recommendations that you explained, for sure you get a perfect IML and a IML label and a happy customer.
Yeah, I think, Andre, applying the IML coatings, UV coatings, or especially the water-based coating, it's not easily, but if you follow all the advice and keep in touch with the supplier, then you can get really good and reliable products.
So, Jim, should we open up the Q&A?
Sure, Andre. I don't actually have visibility to those for some reason on my screen. Do you have visibility to the questions?
Yes, I do have here. Shall I shout some of them here? Frank, one of the questions we pop up here is, what about thermoforming? We explained about blow molding and injection.
Yeah.
What about thermoforming?
Yeah, Andre, you explained it. For example, the IML injection is still a niche, and thermoforming is also a niche, but in principle, you can use the same water-based coating, because you need also some flexibility and some heat resistant. So that's not a problem. So
I have another one here, Frank, that I think can quite easy. Are these coatings also recommended for digital printing?
yeah, for digital printing, there's different systems on the market. That means it could be UV inkjet, that could be indigo, that could be also some water-based system. And in principle, we have also coating for that. I would say in sometimes maybe it's not the standard, but then it's a good idea to contact us.
Jim, I have another here for you. I think it's better for you. Are these coatings available in North America?
Yes, they are. The main products that are available currently in North America, and then if there are some of the specialty products that you mentioned, Andre, we can certainly arrange to have those sent to us from your facility, ACTEGA Terra, and we can keep those in stock here in North America. But the main go-to products like the Aquaprint 200 and such are manufactured here in North America.
Correct. Yeah. Frank, another one here. What about solvent-based coatings? Are they using IML too?
Yes, that's also used in practice. So if you're using solvent-based systems, mostly is popular, for example, in Asia, from my knowledge. Then you have really big jobs, and then you're using solvent-based inks and solvent-based coatings. In some cases, what I see now is that customer changed the coating. That means they stay on the solvent-based inks because they are very resistant against chemicals, and they are changing to water-based coatings because of environmental advantages, and it works. So if you are, for example, using Gravure and you have the right cylinder and the right drying properties, you can also using water-based coatings.
There are really a lot of questions here.
Yeah.
Frank, there was another one here. What is the viscosity of the IML coating? I think we can use the European measures here.
Yeah, and if you are using UV coatings, it depends on the flexo unit, but in principle you can using between 42nd to 82nd in a 4mm DIN. It's very similar to the Ford Cup, and in water-based normal we are using 45-second. But for example, in a Dr. chamber blade, you can using viscosity from the systems between 30 to 60.
Hey, Andre, there's another question here. What should the static charge be?
It depends on the product that you are using, how you are doing that. So it really depends on the how the customer is going to apply the labels inside the mold, Jim. So basically, normally it's sometimes inserted with 3 kilowatts,
Yeah.
sometimes with 5. It depends really from label to label, size of the label, the shape of the product. It's quite difficult to add that one, but we normally, how we test in our lab is we apply some specific kilovolt charge, and then we measure the power that you need or the force that you need to move these labels. And when we do that one, we apply a charge of, I think, 10 kilovolts to see how is the power used in that one.
Okay, staying with that subject, which we learned is one of the most important things, static. What is the most influential in managing static? Adding it when molding? Is it the material or is it the coating?
It's a kind of a combination of both of them. So if you have a film that is really not getting any charge at all, that you might have some problems. But the coating and a good amount of coating is really one of the most important things. If you don't apply the correct amount of coating, then you will not have a good static charging. Right, Frank?
Yeah, in principle, Jim, it is so that by charging the label, you are using high voltage. And it's more important that the label can hold this voltage as a static charge for, let me say, a while of time. It's a short time, but if it don't work, then you will immediately lose this this static load by electrical deloading. And in a film itself, you can load very nice, but if you printed it and coating it, and you have some humidity inside, then the problem started. And it's really, really important to use the right coating, because otherwise you are lost in space.
Yeah. Okay. There's another question here. If we might be able to explain a quality test that could simulate the label's blocking aspect before the injection process.
Yeah, in practice, it's difficult. Of course, if you have a lab, then you can simulate it. But I have to say, if you are using the ACTEGA coatings, you don't have any blocking. So that is that is also a kind of quality what you are using in film and inks and in coatings. Of course, if you are using UV coatings and you don't dry it properly, then you have some uncured UV coating, and then you have blocking problems. But if you follow our instruction, the risk is very low.
Okay, and the same person asked, what would cause wrinkles after the injection process? So in the container with the label.
It's mostly because of the depend on the thickness of the film or how the film is applied, how the label is applied. Wrinkles can have a lot of different reasons to happen, but it's a lot more. Wrinkles is mostly about the film used and how is it positioned in the mold, Jim. It doesn't have so much to do with the coating, actually.
Okay. And someone's also wondering what the name of the lab test is to simulate the electrical static.
Yeah, there's no official norm for that. That is our internal lab test. But sorry that I can't explain in detail, because that is our knowledge. But I can promising that our coating, what we are supplying in the market, that all of them are able to charge, because we know how to measure it and how to control it in our production.
A few people, Jim, normally they put a kind of a plate, a metal plate. They charge if it's static and then stick to the metal plate to see how long it's gonna hold that static. But if you use our coatings and you apply the right amount, for sure you're gonna have this good charging effect. And as well, the customers, if necessary, can send up some labels. We can test for them and tell them how is the charging capability of those labels.
Okay. Then there was a question about the challenges UV has with pinning in more detail. Can you explain the challenges of UV when they have challenges with pinning using UV coatings?
Andre, do you have a good answer?
I can explain that one. Yeah. So we did several tests on these ones, and it depends a lot how much you apply on the coat, how much UV coating you apply. It has really a big influence. If you apply, the more you apply, you have a better static charging, but the more you apply, you have more curling problem. So UV is really tricky if you don't apply correct amount and you have not enough charging. If you apply too much, you're going to have curling. So UV is shown already really tricky on that. And the other problem is we discussed about curing of the UV coatings, and if you over cure the coating, you might have as well some quality variation during the pinning inside the mold. So UV is really tricky because on one side you don't want having static charging during printing and die cutting, and if UV is a little bit more susceptible for that problem. And when you put that one, when you try to apply on the mold, you might have some, the coating will try to avoid getting static. And that's really the difficulty with UV coatings. And that's why so many people use water-based coatings.
Okay, great. There's another question here. Will the coatings work if we want to overlap the edge of the labels? And I think we have that, the AP 115.
Yeah, if you use the water UV, it will be very difficult to overlap. And if you use a special coating like the 150 Aquaprint 115, then you have a good overlapping. Frank, you wanted to add something on that?
Yeah, you're right. So overlapping, it's it's depending of the design of the cup and of the label. And in principle, if you have the overlap, it's very difficult for all materials because you have more thickness in this mold in that age, and in principle, it's a disadvantage, and you need a little bit another coating with more flexibility, and there we provide the 115. But this designs of overlapping, I don't know in the market, but I assume that the designs are in principle below 10% of all designs. So if you don't need it, don't do it. If your customer like it, discuss with them. It's only in
Talk
design.
to Monica. Yep, great. Well, I think we covered most of the questions. Whatever we missed, like I mentioned, we'll be sure to respond out and send those back to everyone. There is some interest in trying to see if they could obtain a copy of the presentation, which we'll address that as well. So
Exactly.
once again, Andre and Frank, thank you so much for your time, and everyone on the call. I know everyone has busy schedules, and we really appreciate everyone's participation in the webinar. We hope to be able to have more topics covered in the future. And with that, once again, thank you very much to everyone. And if you have any questions, feel free to reach out to your local salesperson or any of us. We're all here together as resources for you. And good luck with your IML label production.
Thank you, Jim. Thank you, Frank. Thank you to all participants as well.
Thank you to all to spend 1 hour and learn a bit about IML. Thank you very much for listening to this webinar.
Okay.
Thank you. Have a good day.